A very good morning to one and all. So today we'll have a lecture on MATLAB. Okay, so can anyone say which is the latest version of MATLAB? 14. 14 is very long back. So it is, say, 16B has come to everyone, even 17A. In every March and September they'll be releasing. So this March 17A would have come. Okay, so in every version, mainly if you see, the main difference is they add lot of demos, that is real-time problems. And after 13, the version 13, if you would have seen, it is app-based. Number of apps, like say how mobile is having the number of apps. So this, they made this MATLAB also app-based. So all the tools are just like apps. You have to just click on and operate it. And now they have apps even for from a mobile also we can operate it. Okay, so this is the small intro about MATLAB. So before going into it, any engineering problem, not only engineering, it may be from any field. Why do you want to do simulation? What is the need for doing simulation? Say you take an aero system, like aerospace system, you take any tank system, or you take a motor, or any mechanical lathe, or anything. Or management people are there, they want to just see what is the admission in an engineering college, like what will be the future engineer admission, anything. Why do you want to do some analysis or like simulation? What is the need? You want to optimize it.
Reduce the productivity.
Productivity? You want to increase the productivity, might be. Anything, say, if you take any machine or you take anything, mainly why do we do simulation is, say you have a power system, a grid is there. Now we say it as a smart grid. You have number of solar plants coming and getting connected to it. You have wind plants getting connected to it. So we don't know when a solar or wind plant gets connected to it, what will be the output. Suddenly we can't go and connect a solar plant to it. Sometimes there may be a blackout, the whole system may collapse. Or say you have a Mars mission, where you have to send a space shuttle, okay, and a satellite in the space, or you want to send a space shuttle to Mars. So we don't know what is the different conditions there, when to fire it, how to fire it, all these things, and what is the distance. So what we do a calculation, we do analysis, and we just predict a model. We make the model as such, how the original system will be, same way you will be making a model. Okay, and after that you have to just simulate and see whether you can achieve that output or not. Mars mission, say in one particular angle, when it goes, it has to shift its axis and go in it has to move in another axis. So at what instant it has to get fired, how much ignition has to be given, how much fuel it has to carry, all these things, what we do, we just predict it before. It's like we will do calculations, we do simulations. Once we do the simulation, we see the output. In that also it is not possible, is it? Once you see the output, okay, simulation is perfect, and can you go and send the space shuttle, or you can add a solar plant or something to the system? So then next step, what you have to do? Next step, what will we do? We have to make a small prototype of it. Is it? We will make a small prototype. Say you have a robotics. It has an application that it is a human, it's a human robot, and it has to do some thing like pick a glass and drink water, or something like bring water for somebody. Okay, so first of all, making a robo, and if you start doing it, sometimes a robo will come and catch your neck also. Okay, so it is a dangerous thing there. So what we have to do, first of all, we make a prototype. We just, the simulations or algorithms, we have already done it. We flash it into some hardware. We check for the particular signals coming, whether you're getting the corresponding output or not. Okay, and we just flash into the hardware and we make the hardware work there. Now the hardware is operating. Yeah, once the hardware is properly operating, we can just say it is a prototype. So once the prototype is operating properly, we can say that the same program, when it is implemented in any real system, that will surely work. Okay, that is the thing. So any simulation or anything what we are doing, the main thing is the end is a prototyping. You have to do a product. It's not that I do some programming, I see the output, I'm happy with it. It is not the thing. You have to go and end with a prototyping. So everything is possible in MATLAB. Not only MATLAB, you have number of softwares based on your field. Okay, you have LabVIEW, you have Multisim, you have Protex, you have many PSpice. You have a lot of software for engineering applications, mainly in electronics, electrical, mechanical, these fields. People can go for all these softwares. But one of the common software which is applicable for all these fields is nothing but MATLAB. So MATLAB, mainly if you see there are three, you can divide them into three things. One is MATLAB coding. You just write the code, very simple. You have already, I will just mainly teaching you each and every code. What I will teach you is from where can you learn these codes without mugging it or without keeping it in mind. When we do the programs, each and everything will not come to our mind. Only the logic we have to know. The syntax and everything is available in MATLAB. I'll just tell you where to go and search, how to see how to write the syntax, and how to proceed with the program. So I'll be just teaching you that. And in internet also, there is a very good source where all the IITians and NIT people, those who have done research, they have put their problem. So MATLAB file exchange, that is said to be the MATLAB file exchange. I'll just open that and also show you there all the fields. If you are doing an optimization, GA, genetic algorithm, PSO, and colony, or anything, BAT algorithm, every algorithm are already present. You need not go and reinvent which is already existing. Okay, and all, if you want some Newton-Raphson or Rangakutan or any algorithms, they're already existing. All type of codings are already existing. So these things are already there. Similarly, this is the coding portion. After that, next in MATLAB, you have something called graphical. Some people find it very difficult to go and write codings. For loop, like if then statement and case structures and all these things put together, they get totally confused. Say they want to apply this on a motor for controlling the speed of the motor, or they want to apply on a tank system for controlling the water level of the tank, or something like this. Or you want to have a lathe and you want to control the position, or the position at which you want to have a cut or something. In these places, it is very difficult to write the coding. So what we can do there graphically, you have already a motor, just pick and put it there. You have a stepper motor, put it there. Or in electronics, you want an op-amp, just drag and put an op-amp. Instead of writing a code for op-amp, already an existing op-amp, you just put it. You connect all the elements, resistors, capacitors, you want to make an amplifier or whatever you want to do it there. Then it will give you an output similar to it. So that is a graphical way of implementing something. That is also very interesting. And people find it very easy in Simulink. That environment is called the Simulink environment. You have in Simulink number of toolboxes. You have toolboxes for electrical people, that is sim power system is there. Sim electronics, for electronics people you have sim electronics. For mechanical people you have fluid mechanics, or some other. I'll just show you, I don't remember it much. Then aerospace application, it is there. Then control system, you have control system toolbox. You have fuzzy logic, neural network, and even for optimization and optimization toolboxes there, where you can use GA, genetic algorithm. For PSO or other tools, you have to just download it from MATLAB file exchange and just put it in the current folder in your MATLAB. Then you can start accessing it. So there are all these toolboxes available in Simulink, where you have made a space shuttle system, a system which represents a space shuttle, and you have number of algorithms written in it. Even the coding can be linked with these things. If you have written an algorithm, GA or PSO algorithm, that you want to come and put it in Simulink, that is also possible. You have a program in C or Fortran. You want to put that program here in Simulink, that is also possible using MEX files. So this is the second environment which is available with MATLAB. Third is state flow analysis, that is also there. Apart from that, according to me, the third one, what I want to tell is hardware implementation. You can easily connect a hardware to the system. You can just test it. So you have a number of hardwares. I've worked with DSpace, I've worked with OpalRT, microcontrollers like Arduino, just Arduino. So these, like say if you take an Opal RT or a D space, connecting it directly here in this thing, in the studio, it is a little difficult. So I've brought an Arduino, a microcontroller. I can just show you how to create a graphical user interface and connect an Arduino to it. Okay, a simple thing. Simple. Arduino is a very cheap instrument, which you can say a controller, you can say, or you can say a data acquisition card, DAC card. As a DAC card also it will operate. So there you can just simply connect it to the system easily, and just the signal which you are generating inside the computer, you can bring it out using this Arduino. So that the two sessions are there. So first session I'll be just starting with basics of MATLAB, simple MATLAB. We will say, see now, first I'll be just showing you what are the different commands and everything to become little familiar with MATLAB. The next step what we do is, I will just tell you where are the sources already available in the demos or in the functions, how to find it. That will be the next step, where how to learn it, how to learn MATLAB. So that will be the second step. Then we will go into Simulink environment. I'll just take a simple example and show you what are the different things possible in Simulink. That is some of the basic concepts which you have to know. So the example, you need not worry. It may be a simple example which is common for all the field. That example is not what I want to say. I will be just telling you some concepts which you have to learn in Simulink. And then lastly, we will just connect a hardware and see the output. So this is this whole two sessions which I'm going to cover. Okay, so first of all, just let me show the screen, MATLAB screen. I think all of you can see a screen here. So this is the MATLAB 2015A I've put. This is also app based. So you can see here, it is just like different applications. Here apps are there, like for curve fitting. One second. So these are just like different apps here. So in case of MATLAB, mainly the main windows are, you have a command window, you have a history window, and you have current folder window. So these are some of the windows which are available in MATLAB. I'll be just showing you. I just want to enlarge it. So I'm just... So here you can see, this is MATLAB 2015 version. And you can see the different apps, like say in the apps when I went, it is curve fitting, optimization, MuPad, PID controls, all these apps are there. And this is the command window. You can see here the command window with the prompt here, command prompt. Here you can see an f of x and two arrowheads here. So this is said to be the prompt where you will be writing the command. So this is the command window. This is the current folder. You can see here in current folder, always a program which you write should be, that is, program should be saved in a location which is not the bin of MATLAB. So you can see here, see this is the program file. See, this is the current folder now, which is the MATLAB folder, and which is the bin here. You can see the bin here. One thing you have to remember, don't keep any of your program when you're running in bin. It will give you an error, because whenever you're running a program, the main thing is it will be creating some supporting files. So it will never allow to change it will never allow to change the original MATLAB location. So if you run your program in bin, it will show you an error always. So what you have to do, you can go in desktop or in any C drive or something, you create your own folder, and that folder will be your current folder. I'll be showing you when you do the program, you will understand it. So this is about the current folder. Okay. And after that, say this is the workspace. You can see here the workspace. So here, if you say workspace is a place where all the variables are defined. Okay. Whenever you define a variable, like whenever you declare a variable, here, one of the advantage of MATLAB is you need not declare any variable. Say in case of C program, what you have to do, each and every variable you have to declare it, is it? If it is a number, you just declare it as a double, it is an int. If otherwise, if you're writing some name or something, we declare it's a string. Okay, you have to declare the variable. But in case of MATLAB, you need not declare the variable. Just give a is equal to 10. It automatically it will take as a double. Okay, or it will take it as an int according to its like how it understands, it will take that, it will define by itself. You need not define the variables in MATLAB. And in MATLAB stands for matrix laboratory. Okay, the word MATLAB stands for matrix laboratory. So here you need not define any variable, and all those variables which are given, it defines itself as an array. It will take itself as an array or a matrix form. It takes it in the form of a matrix. So we will be seeing all these things step by step. I'm just giving you an intro. So here next you can see the command history. So command history is what all you type in the command window. So here this was the command window. Okay, you can see here this is the command window. So here what all you type there, it comes in the command history. Okay, so what you can do now, say today you have done the program, you have closed and you have gone, you have just switched it off, and again you're turning on MATLAB. So all those you have used will be in the command history. You can retrieve it. Okay, so this is the command history. From command history, you can even create a whole program. That also I'll be just showing you. Okay, this is the command history. So these are some of the windows which you have to remember in MATLAB. So as I already told you, one is the current folder here, one is the workspace, which you can see here, one the MATLAB command window where you can type all the instructions, and you have the command history. In history, say which is already there. Say I'm just double clicking on this history, that will come here. Okay, and the same thing, I am just again calling the same variable. Just I put up or down arrow. If I put the previous command will come. I'm just taking the semicolon. If you put a semicolon and click, the answer will not come here. It will not show you the answer. But you can see in the workspace. See in the workspace, this x, here x I given 0, 0:1, 4 I have given. That variable came here. It is 41 double. Okay, 41 variables are already here. I'll just show you how this 41 came. It is automatically declaring it as a double. Okay, it is taking it as a double. So here, how this 41 came, that is, you can see here, x is equal to 0.14. In the sense 0 to 4, in the step of 0.1, it will set 0, 0.1, 0.2, 0.3, like this till 4 it will do it. So in order to see that, the same command I have again put, and let me take the semicolon and I have put it. So it has created this 41 variables. See, column, in the form of a column it creates 1 through 6 variables, then 7 to 12, 13 to 18, it goes on like this. Okay, so this is, I just wanted to bring it back. So here you can see the 41 variables are created here in the workspace. So when I double click on this X, now I'm double clicking on the X, an Excel sheet will open. Okay, so here you can see the variable X which was created here, an Excel sheet is created here, and all the 41 variables come here. All the 41 variables come here. So if you have any data, so for neural network or any other thing, you want to train a data, you have already having a very good set of data. That said, data also, what you can do is you can load it, import data. You have an option to import data for any Excel format. Okay, any Excel format can be imported, so you will get the data here. When you import it, automatically it will come in the workspace. So now with that data, you want to draw a graph or something, you can draw it. So now say I'm just selecting the whole data. I have just clicked on this one. So my row data fully was selected. Now I got to the plot. You have an option for plot here. Just draw the plot, bar plot or area plot, whichever plot you want. Automatically, when you click on it, it automatically creates a plot X command here, and it plots the graph for you. So this is a figure window or the graph window. Okay. So what you did, you had a data, you just loaded it. It may be the data of what you have already collected, of some colleges, like students, number of students, or anything, any data, or sometimes some electrical, mechanical people, they would have done some experimentation, and you would have collected the data in the Excel form. So that data you want to draw a graph, directly import it and bring it here, as I've told you, and just click on the plot. So what I did, once again, I'll just show you. When I gave a command, automatically X variables was created. That variable I did double clicked, I got the variable here, and I just clicked. If it is a column, you'll be clicking on this one. Here it is a row, so I have clicked here. And if whatever, say if I want a bar graph, just click on the bar graph, the bar graph will come. Okay, this is how you do it. Now again, what you want to do, if you want to edit this, you want to have labels, x-axis, y-axis, you want to give some name, all these things are possible. So for that, you have to go to the edit, okay, and go to figure properties. So you have something called figure properties here. So click on this figure property. So this window will open. So once again, I'll just show you. It is very simple. I have just clicked on this clicked on this data. I have just clicked the plot. So my plot will come here. So my plot is here on the screen. So now what I did, next step, what I want to do, I just want to edit this. So I will just go to edit and figure properties. So my figure properties will come. Now if I want, say this background is gray color, I click on this background and change it into white. So if I click, it becomes white background. Again, I want to put axis. So I'll just right click, grid on. So my grids are there. If I want to change the shape of the grid also, I can just go more properties and I can just make the grid dotted or any way. Now if I want to change the color of this, just click on that, go to this color, change it into red. And if I want to change the thickness, I can just change thickness. I want to make it dotted, I can make it dotted. Anything what you want to do, you can do it. Click on this graph. If I want to change the font of these numbers, go to font here and just make it bold. And if I want to change the font size, I can make it as 12, 14 or anything, whichever I want, so that this is also thing. And I can click on this graph. If I want to make it a little more small, I can do it here. Then if I want to add label, so right click on it and legend. I want to add legend. So just add legend. So here you can see that this is the data. If I want to give a name for this data, say this is voltage or something, I can write it is voltage. Okay, so whatever things you want to do it here, you can write. Click on this again. Now you want to give x-axis, y-axis, x label. I want to give it as time in seconds. So I can just have this time in second here. You can see it is written here. Similarly, y, I just wanted to write it as voltage in volts. Okay, so that also comes here. So what all changes you want to do here, you can do it. Then you can take the snapshot of this and you can go and paste it in the Word. So it is very simple. This is for already existing data, which is already there. I have just shown you, or which you can import and you can bring it here. Okay, so this I'm just closing it. Now let me go to a PPT where step by step, like now I think you got a small intro about the windows which are available. Let us now go to the PPT and I'll just show you the different syntax available in MATLAB. So first of all, we will start with the syntax, simple things. Then we will go into the MATLAB environment and we will see each and everything. We are just going to see the MATLAB and simulate. Okay, if you have any doubts, you can just clear it then and there. Okay, so this I think you can see the MATLAB simulating PPT. So first of all, I just told you everything. Once again, we will just rush with different concepts. MATLAB mainly stands for Matrix Laboratory. As I already told you, MATLAB stands for Matrix Laboratory. It's a product of MathWorks USA. And this software package is mainly for numerical, scientific, and engineering computation purpose. It is for, yeah, yes. Anyone is having a doubt?
Yes, ma'am. My from here, actually, I know I have then what is the possible for that? This is a single line of multiple now, then what is the possible for that?
What? Excuse me, I couldn't hear it. I think you can remove your external mic. You don't use your external mic. You just come to your laptop or computer where you have your mic. That will be a little more clear, I think.
Ma'am, I want to draw multiple line graph.
Yeah.
Then what is the possible for that?
Yeah. Don't worry. I'm coming to all those things step by step. I just wanted to give you a small intro of these, how it looks. That is what I did. Everything is there. If you want to draw subplots, that is also there. If you want to hold a graph, let's say already you have drawn, you have to multiple graphs, or how to use line command and you have multiple graphs. Everything is coming step by step. Okay, I will start from array. What is matrix? Because many people are there who don't know even simple things. So I'll just start and come. Don't worry. Okay, multiple graphs also I'll be showing you.
Okay, thank you.
So at the end, like if you have, again, if you have a doubt, at the end, again, we will come back to that. Okay, it is there in my PPT. So you will be for multiple graphs also, and even multiple in the same graph to drop subplots also, we will be doing it. Okay, so it is like, say, this software, it is a product of MathWorks USA. And this package has numerical, scientific, and engineering computation. Mainly we use this software for these purpose and for visualization also. So mainly the MATLAB, MathWorks product, if you see, you can divide them into 3 groups. One is the MATLAB for computational language, maths and visualization. For Simulink, that is graphical modeling, I already told you. For prototyping or you want to connect a hardware, you go for Simulink. And one more thing, state flow analysis is also there. Okay, so this state flow, it's a very powerful thing. So whenever you want to, like say, whenever you want to represent a system, how will you represent a system? You have a system and you want to represent it. You either have a transfer function of it or you have a state space, like you have a state space model of it. Okay, so state space model, the advantage of state space model is you can have intermediate analysis can be done with the state space model. So in case of transfer function, only the input output relation. What is transfer function? It is the Laplace transform of output by Laplace transform of input. Okay, so whenever you have a motor or you have a plant or anything, there if you want to do with the transfer function, if you want to do an analysis, it is very difficult because in transfer function model, all the initial condition we keep it as 0. And only for linear time invariant system, you can do this Laplace transfer function model. But state space model, you can do it for variable systems, MIMO system, multiple input, multiple output systems, and their intermediate analysis is also done. And their number of models are possible. That also you will be coming, we'll be seeing into that. State flow analysis. Another analysis is state flow analysis. That is also there in MATLAB. Mostly we don't go for state flow analysis much, but when you want to do complex or in PhD level, when very high level computation, you go for state flow models also. Okay, so now why do we use MATLAB? So that also I've already told you, in C and other languages, you have to declare the variables. You have to specify what is the data type and you have to allocate the memory. But here in MATLAB, you need not do all these things. It is automatic. You have to just give the variable within value, like you have to just define the variable. Defining is also not here. You have to just write A is 10 or you have to give an as in the form of an array. Automatically, it will declare the variable, it will specify the data type and it will allocate the memory also. So that is the advantage of this MATLAB. And here, this package, if you see, it's built. It is mainly built on LabPack, that is linear algebra package written in Fortran. So in older Fortran language, the back end, if you see, all these programs are written in Fortran and BLAS. That is the basic linear algebra sub-programs are used for writing these MATLAB at the back end. And it provides, like if you see, it is an interactive, like what are the things it provides? If you see, it is an interactive environment, and it has hundreds of inbuilt functions for computation. And then if you see, 2D and 3D graphics and animations are possible. Are they all like cut ho gaya? सब सेंटेंस कट हो गया. So sorry for the interrupts, like got cut. So here for 2D and 3D graphic animation also you can use, and there are several toolboxes. I already told you, fuzzy logic, neural network, image processing, signal processing, all toolboxes are already available, where all the functions are put into one toolbox so that those functions you can use. So toolboxes also I'll be showing you. Okay, and it is easy to use. And shallow learning, that is, you don't want, the learning is very simple. That also I'll show you where to learn and how to learn. That is also very simple. High computational speed it has, and it supports all, like all the like operating systems like Windows or Unix or Linux, any operating system this will support. So that is the advantage of MATLAB. So here, as I already showed you the MATLAB, like you will be having an icon in the desktop MATLAB. So you have to just double click on it. The icon looks like this. The window will open. Or you can and if you want to quit this MATLAB, what you have to do, you have to go to File, Exit, MATLAB, so you can quit it. Okay, so this will be the MATLAB window, which already I have shown you. The same window is here. And MATLAB windows, if you see, mainly there are three main windows. One is the command window, graphic, figure window, and edit window. So this also I already showed you. Command window is the place where you wrote what is the X value. Graphic or figure window, the graph came in the window, that is to be the graphic window. Edit window I didn't show you. Edit window is nothing but the M file, where you create the M file. So that also I'll just show you 1 second. So here, say this is the MATLAB environment, and I already told you here this is the command window. In command window, when you write the program, you get the answer then and there. Okay, you saw the answer there itself. Say now I have written a program and I am clear. Okay, my program is full and I have sequence. You have done it properly. Now what you can do, you can create your own function, or you can create your program there. Now you can put all those functions together and create your program. So all those things which you have already written here, it is in the command history. So say I declared a variable X, and after that I plotted this X. Okay, so what I can do, I can just select these two. I have selected these two. Just right click on it, and I just give create script. You can see an option here called create script. So just click on that create script. Automatically this M file is open. Okay, this is a program. So this only 2 lines are there. I can even show you for bigger programs. We will be seeing it later. So here you can see, so our one more program I'll just show you. This is a program to draw a stem. Okay, so here X value and Y value is defined, and this, say this program. So X value is defined, Y value is defined, and stem is a command to draw a plot. So I'm just right clicking on it, create script. So automatically this is an untitled script file created here. Now what you can do, run this. You can just go here and run it. Okay, so once you run, automatically it will give you the thing. Or what you can do, you can go here to save, and you save this as some. So now the extension is .m file. Okay, you can see here the extension of this is .m file. You can give any name to this and save it. So let me give this name as my example1, exp1, and I shouldn't save it in bin. Okay, it is better you save it in some other location. I am just saving this in my desktop, and I am saving this. Okay, So now what I have to do, I have to go to this desktop. Okay, desktop current folder. How will you select the current folder? I'm telling you. So here there is a small folder here. You can see that symbol. Once again, I'll just enlarge and show you. This is the symbol here. The browser for folder it's given. No? So that is the symbol. So that, just click on that. Okay, and just choose desktop. Select folder. So now what happened? You can see here, see user Shimmi desktop is my current folder. My bin folder has gone. Okay. So now what you can do, you can just go and run this program. So here if you see, I saved it in the name exp1. So that will be, say, this exp1 is there in the current folder. Okay. So now you just go and run this program. So automatically, see, I didn't write here exp1. So that is a function now which is being created. So, or you can say that is a program which I have saved. So automatically it is called here and this program is here. Okay. So here in this, one option is you'll write X and you'll see what is the value. Then you'll write Y and you'll see what is the value there. And then you write the stem and you just plot the stem command. So that you can one by one, you can write it in the command window and you can do it. Step by step, you can do it. Okay, these command stem and all I'll be teaching you later. Just I want to show you what is M file, creating an M file. So in command window, you will get the answer then and there. Okay, so you are writing a whole program. You want to see whether you have declared the variable correctly or not. There should be 100 constants. So you are writing it. You are not clear that whether your program will create that or not. So what you will do, you will just write the program there and check it. Okay, it is clear. Then you go to the next step, next step. When the whole program is clear, now you will go to the command history. What you can do, select everything and create a script file. Or if you want to go and write a script file directly also, what you can do, you can just go to home, there, new script file. The option is here. You can see here, if you go to home, new script file option is here. Okay, so you can write that also. You need not go and write it in the command window. You can go open the script file. Script file will come here. So let me write A is equal to some 12 and my B is equal to some 45 and C is equal to A plus B. So this is a small program I have written. What I can do is I can just save this as my program. Okay, let me save it. I'll go to the editor and save this program in some name. You can save it as sum 1, 2, 3. So like sum is a inbuilt function. So sometimes it will not allow you to save it as sum. So I write sum 1, 2, 3 and I'm just saving it. So again, it is in the current folder. Now you can run this program. Automatically, you can see the sum here in the command window. Okay, sum 1, 2, 3 is called and C is equal to 57. Okay, so it is not necessary that you have to write it here, go to the command history and do it. You can directly go to home, new and create a script file and write your whole program. Okay, step by step we'll see how to write program. So this is only simple things I am teaching you. So next, these are the different MATLAB windows. Okay, so this edit window is nothing but the M file which you created. So that window is said to be the edit window. So here again, this is the command window, this is the figure window, and this is the workspace, and this is the edit window or the .m file where you will be writing the program. Okay, so next is command window. In the command window, that is the main window, you have this prompt in this where you write the program. And graphical window, that also I have shown you. Edit window, that is the M file that we know it. Sub window, so the history window. I showed you the history sub window, and the workspace also, you know, that is also a sub window. Okay, so here the command histories, this also I already showed you how to like go to the command history and create an M file. That is also over. Okay, so create an M file, this is also over. Workspace is also over. Pop-up menu, right? Yeah, this is also okay. So now we'll go to the file types. There are different file types, mainly in MATLAB. If you see, M file, MAT file, and MEX file. 3 types of files are there. M files, what I showed you now. In the edit window, when it gets saved, it comes as .m files. Mat files, when you have a data, say in X was a lot of 100 or 41 data was there, that gets saved as a binary data. So that is the data in workspace which gets saved as binary is saved as .mat file. So this data mat file can also be again loaded and you can use it. Next is mex file. Mex file is, say, whenever you have some program in C or Fortran that you want to bring it here, you convert it as a mex file. You just write the program, you change the program, everything with mex, and you save it as a mex file, and then you will be calling it. So any C program or Fortran program, when you want to run here, you have to convert that as a mex file, and then only you can run it. Okay, so you have procedures. I'll tell you where to learn all these things. So you will get from MATLAB File Exchange. I'll just show you the locations. So this is about the file types. So first is the M file, that is the script files, and the function files are saved in the form of .m files, that is ASCII text files. You can say they are standard ASCII text files. Next is mat file. So these are the binary data files and have .m file extensions and can be loaded by using the load command. Okay, so using load also you can load it. So any data in MATLAB, many data are already loaded in their in the C prompt, like in the C program files. Already number of examples are there, they existing. If you want to load it, the command is load, and those those datas are in the form of .mat files. Okay, next is mex file. As I already told you, these MATLAB callable Fortran or C program files, they are said to be the .mex files. So here it's a small example. It is showing where mex setup. Please choose the compiler. It will ask you. So here actually I don't have this compiler, so I'll not be able to do it now. So this was a hello program which was already written here. So you can see here hash include mex.h is done, and then you have to write the whole program. And once you just run it, mex hello.c, when you're calling this m file, which was the mex file which you have already .c file, I'm sorry, the .c file which you have written, you call mex hello.c, automatically it will give you the answer. So this is how C programs are usually called. Okay, so next is commonly used commands. Some of the commonly used is clock. When you write clock on the command window, that is the command prompt, automatically it will provide you the clock time and date as a vector. Okay, and date provides a string, and then version VER, if you give it, gives you what is the version with which you are working. So this PPT I'll be giving you, and it will be there in my slide share also. So you can just go and work with it afterwards. Okay, so I'm just, some of the things which are not much important, I'm just not writing it. You can just try this. Next is PWD, that is it provides present working directory. Then CD to change the present working directory. DIR to list the files bar folders. MKDIR, make a directory, you can write it as MKDIR. Then LS, that is list the files. Then path, display the MATLAB search path. Then edit path, copy file. So see, copy file is a command to copy. It copies a file. So these are some of the command. Who, if you give it, lists the variable currently in the workspace. Who's same as who, but gives more information such as type, size. Then what gives you the list of .m files, .mat files, and .mex files on the disk. Then clear all, that is the command used for clearing all the variables in the workspace. Clear x, y, z, that is if you want to clear a particular variable, you will give that variable name there. Mlock function, that mlock function is used to lock a function so that you will not be able to delete that function. CLR, that is clear screen, and CLF is to clear the figure window. So these are the different commands there. Then control C, that is stop the execution of a function. When you want to quit MATLAB, you write quit, and or you can even the same thing, exit also. If you go to the file in MATLAB and go to the last thing, exit, one option is there. If you go, it will exit MATLAB. Okay, help commands are help. If you write, it will list all the topics there. Then help topic is there. Look for string, that is also there. Help win, that is open the help window. Then help desk, open the web browser, online help, then demo is there to run the demo program. Okay, and coming to the variables, variable in case of MATLAB, if there are 14 fundamental data types available, or classes you can say. So these are the things you can say. Data types in MATLAB, so it is always, I already told you, it is given in the form of an array or a matrix. So you have characters, numeric, cell, structure, Java classes, and function handles. So in numeric, if you see integer 8, int 16, int 32, single, uint 8, uint 6, that is unary int 16, uint 32, double, spas. So these are the different data types available. So here, what is a cell if you see? Say already the int, double and all, you have already seen cell. So cell is used for storing dissimilar kind of data type. Okay, one can store array of different type and size. So here you can see A is 1, 2, 1, 2, 7, 8. Okay, so it is an array which contain 1, 2, 7 and 8. And B, if you see, it's a matrix. It is a 3 into 3 matrix with 1, 4, 5, 6, 8. These are the elements of the matrix. And one more C variable is defined, which is zeros 2, 3. The sense 2, 3, like 2 rows and 3 columns, zeros. It will just create 0, 0, 0, 0, 0, 0, like that. C is there. So now D underscore cell, when you want to create a cell within parenthesis, if you put A, B, C, A, B and C are cell arrays of different data type. These are the of different data type and size. Okay, so these together you can put it in a cell. So I'll just show you. I'll just copy this. Here, first of all, let me call the first thing A. Okay. Excuse me. So here you can see the A is equal to 1, 2, 7 and 8 I have given. I'm just taking the colon here at the end and I'm just clicking. So you can see A is equal to this. It will automatically give you an array 1, 2, 7 and 8. Similarly, let me take the next variable B. So here B, you can see here when I gave B, 1, 4 and 5 are the first row. When I want to go to the second row, again I have put here a colon. Okay, again 6, 8, 9, again a colon. And again 9. So there are, it is a 3 into 3 matrix. So otherwise say you can even, like say if you want to give an array and you want the array to be a colon. So what you can do, one thing is you can transpose A. A transpose, if you give, automatically the row becomes a column. Or otherwise what you can do, you can just give comma, like one comma, like in two types, two ways you can write this matrix, array, 1 comma 2 comma 7 comma 8. That also gives you the same way. It's not a problem. If you want to convert a row to column, you will be giving it transpose. It will automatically convert to a column. Okay, so here again A transpose I am giving. So automatically if A is in the form of a row. Already it is in the form of a row. So when I give A transpose, it is giving me the transpose of that. Next, C. I just want to see C. What is C? C is zeros. So you can see here, C 2, 3. So it gives 2 rows and 3 columns, 0. Now I'm just creating a cell. So I can see here, D underscore cell. So here D underscore cell, if you see, it is 1 into 4 double matrix, the array, then 3 into 3 double array matrix and a 2 into 3 double matrix, which is coming inside this cell. So if you want to access a particular cell element, you say first element I want to access, I can give this command, that is D underscore cell 1. Say D underscore cell 1. So the first element in this cell, that is 1 into 4 double matrix. So that will come. Same way, if you want to access the third one, you can just give 3. So automatically the last element is there. Okay, so this is how you will be accessing the cell array. So next is structure. So structure is, that is also a data type used in a similar way of cell array. But here, if you see, here you have the string type. So you can see ABC dot name. You want to give a name or a string. So different. These are also different data types only that can be put to a group there. So here it creates a structure named ABC with 3 fields, that is name, roll number, and sex. And many sets of values may be assigned to these 3 fields. So many values also you can assign. So this program also we will just try now. So here the first one is ABC name. So I'm just giving the first is, I'm just writing ABC dot name. So it will give me ABC. Name is nothing but Shimmi. So next is the roll number. ABC roll number is this. So the ABC roll number is 90 thing. Next we had the sex, that is female. Here if you see, sir, ABC is a structure with name Shimmi, roll number is 9076, and sex is female. Okay, so this is how you create a structure. So coming to the different operators. I'm just not going any, I'll just show it here itself. So the different operators, if you see, MATLAB operators can be classified mainly into 3 categories: arithmetic operators, relational operators, and logical operators. Okay, so the arithmetic operators are that like addition, multiplication, all these things. Relational are greater than, less than, equal to, and logical, you know, and, or, and all these things are the logical operators. Next, so you can see here the arithmetic operators. So here, these are the arithmetic operators. I think Fi is not working. Anyway, arithmetic operators, you can see addition, subtraction, multiplication. The symbols are given here, and it is a known thing. Arithmetic operators, you can say plus, minus, multiplication, division, addition. Okay, for power. And this is how you just represent it in MATLAB. Then relational operators. Relational operators, you have less than, greater than, equal to, almost same. Not equal to, it is a minus than, equal to. If you put, it is not equal to. So here you need not keep all these things in mind, because in MATLAB you can just go and in help, if you see, all these functions will be already existing. Logical operators, if you see, if you just go to the help and put logical operators, all these operators will come. So you need not remember it. Ampersand is for and, or like it's not one, it is a line, straight line, and then you have not symbol, then XOR. So these are the logical operators. Then the hierarchy at which it operates. Okay, so the hierarchy is, if you see, hierarchy of operation first contains contents of all the parentheses within the bracket. What you have put, that will come, are evaluated first, and then it goes into the inside the parentheses. For transpose, then power, then complex conjugate transpose and matrix power. Then comes the unary plus, unary minus, and logical not operation. Then comes the multiplication, right division, left division. So in right division is, if it is a A dot slash B you have written, that is right dash, then A divided by B it will do. Or left division, A dot left division B means it does B by A. So the division, the slash what you put is also very important. If you put towards right, what will happen? The first variable divided by the second variable. In left division, the second variable divided by the first. So in multiplication, according to the division what you give, that also division comes, then dot division, then comes the multiplication, then matrix right division, left division, addition. So dots multiplication is nothing but the array multiplication. The another one is the simple multiplication. Then addition, subtraction, colon, then less than, all the less than, equal to, these symbols come. Then at last the logical AND operation, and last the logical OR operation. So this is the hierarchy. You have the, and this is how it operates. Then you have the built-in functions. So there are a number of built-in functions available. Besides the simple arithmetic operators on variables, a number of built-in functions like sine, absolute, if you want to find ABS, if you want to find the square root, SQURT, EXP, exponential, log, so Bessel, gamma, all these functions are already available. How will you write? Function and give the function name, like function, then the function name, and then the variables. You will just write the variable. If you want to find the square roots, you write square root within bracket what variable you give, automatically it will find it. So if you want me to show SQRT, square root SQRT of 16. If you write square root within bracket 16, automatically your answer will come. So this is how you just do the functions. So you have to just write the function name, that is square root or whichever, and give the variable name. Sign, you want sign, all those things. Next is complex numbers. So if you want to write a complex number, you can write it in all these three forms. So x is equal to -4 plus j star 8. That is also you can write -4 plus 8j directly also you can write, or 8 cross j. Okay, so 8 multiplication symbol j. So these three, if you write, it creates complex numbers. So I can just show you that. So you can see here x is equal to -4 plus j8 is written. So anyway, in all the three forms which I showed, you can write. If you want the real and imaginary part of that, automatically you can so first you want the real part, so automatically -4 it's given. Imaginary part, say x underscore image is equal to imaginary part of x, -4, and the imaginary part was 8. Okay, so these values you can bring it. Once again, I'm telling you, don't get worried. I'm showing you a lot of functions and all these things. At last, I'll show you a place where you will get all these things. Okay, there you will be finding, okay, this is very simple. You need not worry. I'm showing you a lot of things, and it is not, it is very difficult to remember all these things. Suddenly in square root, you use some other software, so suddenly you know what is the command. You need not worry. You can just go and search for it. You will get the syntax, everything you will get. Okay, that also, first of all, I'll show you so that you will get little more confident. So here, this is the MATLAB window. Can you see a small f of x here? You can see here as f of x here. So this is a place where you can get all the functions. Okay, so just click on this. So what will happen? A window will open, and there all the functions. So in mathematics or in Simulink or in all the toolboxes, all these things are already existing. So here you go to MATLAB, Simulink, and all these things are there. Or in MATLAB languaging, so mathematics. We are seeing all these mathematics and graphic functions. So in mathematics, if you see again elementary mathematics, linear algebra, or random numbers, or whatever things you want, you can just go into this. So say if I want to go to the elementary mathematics, arithmetics, again plus, addition, unary plus, minus, all these things are existing here. Okay, so here this window is not coming. कहाँ ही आएगा? नहीं, यहाँ भी आता है. नहीं, वो I think ये कई बार ना जो स्क्रीन शेयर नहीं किया. हाँ, नहीं, सर के लिए डिफिकल्ट होगा ना, सर को दिख नहीं रहा है. यहाँ से मुझे भी नहीं दिख रहा है.
मैम वो कई बार है ना, ये वाला जो सॉफ्टवेयर है वो फिर दोनों जगह प्रेजेंट नहीं होता था. सर आप यहाँ आ जाएंगे तो
मैं अभी देख रही थी कि दिस इज नॉट डिस्प्लेड हियर. ओके, सेंटर्स को जा रहे हैं, बट वही है कि सर के लिए यू कैन जस्ट पुट योर चेयर देयर एंड सिट इन फ्रंट ऑफ दैट इटसेल्फ. You can come here also, otherwise you can come here, you can see in my system itself. You can put a chair here, Rajan. It's not a problem. Okay, so here if you go like once again I'll just tell you, see you have an f of x here, just click on this f of x, you will get all these things. Say this was like this, so you have the MATLAB, all the different MATLAB languages, mathematics, elementary, whichever. Say optimization toolbox, I want to see what are the commands in optimization, I can just go. Or mathematics, just go into mathematics. If I want to see graphics, how to plot, so 2D plot or 3D plot, just click on that. And I want line plot or polar plot or whatever plot, line plot, click on that line plot. I want the plot command, or I want to draw command plot yy. That yy, what will happen is it will draw the plot with two y-axis and single x-axis. Okay, say for example, you have a plot where you want to plot the voltage and current. Voltage is 230 volts and current is 0.2 amps. Both of you, if you put in the same y-axis, what will happen? The current will not be seen. It will be near the x-axis, 0, and y will be more. So I can just show you that. Say, for example, you are just drawing a plot like this. One is the voltage plot. You have just drawn the voltage 230 volts and current is very less, 0.2. So this is 230. Here it is around 230 volts and current is very small. It is almost here. You will not be able to see it also. In such case, what you can do is you can draw a double graph where voltage will come this side till 230. Say voltage can be plotted like this. Voltage will come here and the other graph will come here. See, this will be defined from 0 to 1. So your 0.5 or something, say your current value is 0.5. That also will be, your current is 0.5. So that will also be displayed here this side. So this is plot yy. Okay, so here you can see the plot yy. So whenever you click something, say plot command, automatically you will get everything here. Plot x comma y, plot line space, all the syntax are here. So you can see here, all the syntax are coming here. More if you want some examples, you want to draw that and see. What you can do, go to this plot 2D, go to more help. So in more help, it will give you everything. It will give you examples. It will give you the explanations and everything is available. So this is the place where you want to learn function. So you can see here, it is for 2D plot, just plot command. So plot xy, say example is given here, plot xy line space. If you want to plot multiple things, like say here, example is given here. So automatically you can see here. Somebody was asking me for double plot or multiple plot. I'll be just showing you again. But this is how, say, x is there. X is defined, then y1 is defined, y2 is defined, and y3 is defined. So what you can do with the same x comma y1, x comma y2, x comma y3, how you want that also. So automatically those plots can be seen. So that's why I said, whatever you want, don't get afraid. Everything is there. You want multiple plot, you want x this side, y that side, you want to make the plot upside down, you want to make a semi-log, whichever thing, you just go and search here, you just search, you will get it. And there are other places also where to search. You have help window. This is one place you want to search, you can do it. One more is the help window. I'll just give you the help window. See, help window is there in the home itself. Here, help. Go for documentation or example help. Example also you can go to documentation. Everything is here. You can see here. MATLAB, Simulink, Aerospace, which help you want, all these demos are already existing. So if I want to go to MATLAB, go to MATLAB. In MATLAB, again, say getting started, how you want to start, each and everything is given here. Even video tutorials are there if you're connected online. Say tutorials for all these calling function, 3D plots, 2D plots. So this is for, say, example, I choose for 2D and 3D plots. So one by one, simple things, they have explained everything. X is equal to 0, pi by 100. You can see an example here for drawing a simple graph. So just what you have to do for learning purpose, that's what I said, when you want to learn, just click on this, copy, Control C, and just paste in your window. So you will learn, okay, how this plot came. Now you don't know how your X and Y is defined. What you do, just up arrow. So first of all, you will get the X variable. Just take off the semicolon there. Okay, sorry, the semicolon, and just click on it. So you will understand how these variables are defined and what steps. So it's a very big thing. See here, if you see 0 to 2 pi. Okay, pi is 3.14. So 2 into 3.14. 0 to 3.14, 2 into 3.14, and pi by 100. 3.14 divided by 100. So 0.0314. So in that steps, it has created the X variable. Then Y is nothing but sine of that X. So you can just put, after this, just take the Y variable. Y variable, you just up arrow, you get sine X. So now if you see, all these sine of those X variables are there. Okay, so this way, step by step. So go to the example, whichever example you get, you just copy it and do step by step and learn it by yourself. MATLAB, it's very easy. One thing what you have to do is you should have that capability to learn. Everything is available. They have given step by step each and everything you have in this. And what I am showing you also, I have just taken from these help only. So there is nothing. Got stuck, I think. एस्केप नहीं, मैंने एनलार्ज नहीं किया वो कर्सर, वो कुछ और कर दिया तो ये प्रॉब्लम हो जाएगा. Okay, so now again we will go to the showing this one, I think. Okay, so we were seeing the built-in functions we saw, then we saw the complex numbers. So I told you complex number also. Then after that, in complex functions, complex numbers, you have a number of other functions like square root. If you want to find the magnitude, so if you want to find the magnitude, what you will do, you will write the square root of the real term square plus the imaginary term square. So that's the same thing. Or you can do absolute of x. If you put absolute of x also, it will give you the this square root, well, this magnitude only. If you want to find the magnitude, that is square root of x squared plus y squared, the same variable will give you the absolute. Angle, if you want to find angle of x, you can use a tan. When you want to find the arc tangent function can be used for finding the arc tangent. And then Cartesian to polar and polar to Cartesian, these functions can also be used for finding different complex, these are the different complex number functions. So these things you can try. Okay. Next is the assignment statement. So assignment is when you are just having a variable name. You can see a variable name is equal to the expression. So here circle underscore area is equal to 3.14, or you can write that pi into r, where r is the radius. You have to define the r variable before itself. R is equal to 0.5 or something, and if you give like this, this will give you the this is just for assigning a statement. You have to use the equal to sign. So these are different assigning statements shown here. We'll just see some example for assignment. So here, say you have a function given f is equal to a plus b minus cd by e the whole squared. So when you are, and a, b, c, d, all these variables are given. So when you want to write it in MATLAB, what you do, a is equal to 1, b is equal to 2, c is equal to 3, d is equal to 4, e is equal to 5, and you will write the function. So same thing, f is equal to a plus b minus c into d. You have to put the multiplication symbol divided by e, and for power it is the exponential symbol you have to put to the power, that is to square. You will be writing it like this. So okay, so this, just let me copy, Control C, and I have to just paste it here. Automatically say a, b, c, d, all these variables are there, and this was the function I gave, and automatically I got the function value here. Okay. So one more example is here. So for logarithm, when you want to find the log, similarly these things you can just try this. It is very simple. Then vector and matrix. How to write a vector or a matrix? So this is what I already told you people. Same way, when you want to have a row vector, you just p is equal to 1, 2 and see p is equal to 1, 2, 4. Or same way, you want to have a row vector itself, you can write p is equal to 1. So you can write it in this form also. So you can see here p is equal to 1, comma 2, comma 4. That also give you a row matrix similar to this. And when you want a column matrix, q is equal to, you put the semicolon here itself. Okay, when you put the semicolon after each element, automatically it becomes a column. Or what you can do, you define a row and put a transpose. Then in that case also, it will give you a column. Both are possible. For writing a matrix, say 4, 5 minus, say what you do, 4 and 5, one row you want, then you put a colon and then write the next row. So this will give you a vector or a matrix. Okay, so then next, some of the operations of vector and matrix, they are vector transpose you want to do. Then what you have to do, y is equal to x transpose. Then mean of x, it will give you the average of all the elements. The length of x, it will give you the number of elements in the vector. Maximum, it will give you the maximum value. Minimum, that will give you the minimum value. Product of x, it will give you the product of the elements of vector x. So these are the different commands that also you can just go through. There are more than 82 types, so I'm just rushing with this. Okay, so now matrix relation commands are there. I of n, 0 of n, ones, then size A, del, that is delta of A will give you the determinant of the matrix. Rank of the matrix, if you want, you can put rank of A. Then eigenvalue, if you want, you can put EIG of A. Trace of the matrix, that is the diagonal element. You put A, trace of A. Then if you want the diagonal return, calculate the sum of the diagonal. So trace will calculate the sum of the diagonal. If you want the diagonal, you can write DIAG of A. Inverse of the calculate the inverse of a matrix, you can write inverse of A, INV of A plus 2. If you want to find the sum of two matrix, plus A comma B, subtract it minus A comma B. You want to do multiplication, M times A comma B, and A colon, that will give you the transpose. That already we have seen in the other case also. So same way here, matrix relational operators are also, commands are also the same, almost same. Next is partial fraction. So you have a function and you want to find the residue for it. So first what you have to do, you have to define the numerator term, you have to define the denominator term, and then put residue of this. That will give you the, first of all, it will give you the residue. R will give you the residue. P will give you the poles, how many poles are existing, and K will give you the constant. So for one example, if you take, you will understand. Say partial fraction of, we want the partial fraction of a function given here. S plus 1 divided by s cube plus 7s squared plus 16s plus 12. So now when you want to do the partial fraction, sometimes a constant may be there which can be taken out. Say if it is 2s plus 2, that 2 will come out as common. So that if such a term is there, k will be existing. Otherwise, k variable will be a 0. Then residue. Residue is that which comes at the top. Say for example, if there is a pole of 2 or say 1, so it is say 5 divided by some yes plus 1 of the pole. I am not sure, when we do this program we will understand. So this is 5, or you can say this like 5 is looking like s, so let me make it as a 6 or something. 6 divided by s plus 1. So here this is a residue, the one at the top, r, that is this r, and pole is nothing but minus 1. Okay, so for this you have to find the partial fraction. For that function, when you run that in MATLAB, Mm, 52 था. Yeah. Oh, again I did this. ये आ रहा है, MATLAB नहीं आ रहा था ना. Flowing, say here in the previous case, when you write the command n is equal to 1 comma 1, because say numerator s, that one variable, and this 1, to all the both the elements are 1 1, so numerator will be defining as 1 1. Denominator, how will you write? S cube is 1, so the s squared element is 7, 16 and 12. Now you have to write residue of numerator comma denominator, so you will get the answer. R is minus 2, 2 minus 1, so it is minus 2, 2 minus 1. Poles are minus 3, minus 2, minus 2, so it is a double pole here. Okay, so 2 is repeating, minus 2, minus 2. So that's why you will have it as s. When you write the function g of s, it is s plus 2 and s plus 2 the whole squared. Okay, and here, if you see, this is minus 2 is the residue and the pole is s plus 3. That is minus 3 is the pole. And k, there is no constant outside, so k is null vector there. So this is how you will get the polynomial. So I'll just write it and show you. So this one we let us take. Okay, so here if you see numerator and denominator, I am writing it, and then residue. So you can see here residue is R, P and K value have come. So R is minus 2, 2 minus 1, P is minus 3, minus 2, minus 2, and K is the null vector. So here I just define the numerator. So numerator term, if you can see here, n would have come here. Okay. So you can see here the numerator n is 1, 1. It is already defined there. And denominator term is also there. Since if you want to see the numerator again, you can just put n and c. N is the numerator and d was the denominator. Okay, so residue of that will give you the partial fractions. Next, we will see the polynomial. Okay, so polynomial, if you see, it is represented as a row vector again. It is entered with coefficient s terms in descending order. So multiplication, for multiplying two polynomials, you write convolution CONV of P1, P2, and given the polynomial P1 and P2, multiply them. So P3 is equal to convolution of this. For example, you can see a program here. P1 is given as S1 plus S2 and P2 is given S squared plus S2S plus 1. So as already I said, P1 will be written as 1. So S element is also 1 and then plus 1. So you can, this S element is 1 and here also 1, 1. So this matrix will be 1, 1. And P2, when you write here, this is 1, 2 and 1. So you'll write it as 1, 2, 1. So if you write convolution of P1, P2, automatically you will get the results obtained is 1, 3, 1. It will multiply. This is a convolution of these two and it will give you the variable like this. So when you want to again write it in the polynomial form, say it is 1 means s cube, here s squared, yes, and 1. So you get it in this form. So next is coming to the graphics, plot command. Okay, so two-dimensional plot. Already we have seen some plot. So when you want to plot a command, the command is plot of x comma y. So here x and y has to be first defined. So y is equal to x squared, where x variable, draw a plot for the equation y is equal to x squared, where x variables are from 0 to 10. So what you put, x is equal to 0 to 10 in steps of 1. So that is what is shown here. Your variable is 0 to 10 and you are just keeping the step size 1. If you want, you can keep it as 0.5. So it will take in the steps of 0.5. And y is nothing but x dot exponential of 2. That is, here it is matrix multiplication because x is here as a array. So when you want to multiply with an array, like, sorry, not multiplication, exponential with an array, you put a dot here. If you want to do array multiplication, dot into that star. Okay, so star, that dot means that it is array multiplication, array exponential. Like each element it has to do it, and plot x comma y. Okay, so now let me take this very simple thing. We'll see a lot of plot commands now. So when I click it, automatically the figure window would have come. So this is the thing. So x x is 0 to 10 in steps of 1, and y is the power. So that's why you can see a exponential curve. Okay, so this is for plotting two variables. Very simple. Now we will go step by step. Next is when you want to print a label. Okay, you want to print a label. Then to make a plot more understandable, the axes are labeled and title is provided on the top of the thing. So X label, then it will give the X variable. Okay, X label will be there. Y label of within parentheses, you give within the bracket and within single quotes, you have to write string, whichever string. String 2 is the second, say time. Then you have to write time, or say x-axis is time and y-axis is your voltage. Then you will be writing here voltage. And you want to give a title like VI curve or something, you can give the title. So you can just see a example for that. So here, given a better illustration for same thing, X label and Y. So it show, like say, let us take a small program where a variable a is equal to 10 e to the power minus t for t is equal to 0 to 5. So t variable t is given as 0 to 5, and you have to a 10 e to the power minus t. So this is the program which you have to plot. Okay, this is one. So first of all, t I have to define. So what I have written, t is equal to 0 to 5 in the steps of 0.1. Okay, this is the first step I did. Then a is equal to 10 into. So here it is given 10 e to the power minus t. So 10 star exponential minus t. Okay, so t I have already defined. So you have to define the t, then only you can use it here. Then plot t comma a. Now I am labeling it. X label is time in seconds. Y label is within single quotes you have to give output, and title is plot of a is equal to 10 exponential this. Grid on, it will give you the grid lines. Okay, so now from here I am just copying it and let me paste it. Here you can see t is equal to this, a is equal to exponential of 10 exponential of this, plot t comma a, x label, y label, title and grid. So let us see the graph. So here, so in the graph you can see here, this is the x label, you can see it, this is the y label. Okay, output what we have given, this is the title, plot this, and this is the grid lines. So you have turned on the grid line. So this is for a simple plot. Next is entering a text and plot. You just want to enter at a particular distance, you want to enter some, say in this graph itself which you have seen here. In this graph at this particular instant I want to write something on this graph here, or for that two options are there. One is you can write the text and with the coordinates you can give the x coordinate, y coordinate and write the text here, or get string, and you can write the string name here, and you can just in get string you need not define the x and y variable. You can a cursor will come and you can go and click with mouse click, it will come. So we'll see the example, you will understand it. So here there is a simple example where we have to use get string y is equal to 3x plus 5 for x variable varying from 0 to 10. So x is equal to 0 to 10 in steps of 0.5, y I have written 3 into x plus 5, plot x comma y, get string, it's a straight line. I want to write this, it's a straight line. And now I have to grid on, label we have already seen, title, all these things. So I'm just copying this. Okay, so now see the plot is there. The plot is, say, x-axis is here, y-axis is there. Get string when I gave this cursor will come. Okay, and this it's a line where I go and click, there it will write. Say this is a line, I was just want to write it here. So I'll just click on this. So it will write it's a straight line. So that is getting a string at a particular location. In the same graph, if I want it in some XY location, that is also possible. So what you can do is, in that case, text 3 comma 10. In that 3 comma 10, I will be writing this, get this string. See here, I'm giving the single parenthesis. Okay, get this. It's a string. So x is 3 comma 10. It's a straight line. So what will happen? This automatically in. So here you can see this is 3 comma 10. It's a string automatically comes. So if you want to write something in a particular location, you can just give that location. Otherwise, get string. Get string is better because you can go and write it wherever you want it. Then axis control. So if you want to control the axis, you want to write x-axis should be from 0 to some 100. Y-axis should be from 0 to 2. That you can specify by writing the axis x minima, x maxima, y minima, y maxima. Within square brackets, you have to write that. And with this axis, it's a function. So you have to write it within curly bracket. So this is how you will be defining the axis. If you don't have, define the axis, it will take the default axis. So you can see here, for example, first we are just going to see this one. A is, here I have given the minimum value, the maximum value of x, minimum value of y, maximum value of y, and just writing axis of A. So for the same graph, say x-axis I have just defined as -3 to 3 and y-axis 0 to 10, axis of A. So automatically you can go and see the axis. So it has defined from -3 to 3 and 0 to 10. Okay, so this is how the axis of A is coming. Since I have not specified, if I don't specify, it will take the default. Next is, say, I can even write it in this form. I can give the axis like this also. So this is also a format that C, that is x-axis is minimum maximum you can give, y-axis minimum maximum, and you can write it. This is the syntax I showed you within curly bracket C and D. If I want to see it, C within curly bracket, then within square bracket C and D value if you give, automatically that also will give you the same. So it was the same thing. So it is coming the same. Okay. So next, if I want to redefine it, infinite and this is also a way where you can define the axis. Axis of -5 to 5 is the x-axis. In minus infinity to 10 is your y-axis. So you can see the graph like this, -5 to 5, and this is infinity. Minus infinity, say it is starting. That's why it is coming in the center of the graph, and then 10. 10 is the upper limit. So you can just define the axis also according to your requirement. And if you don't want axis auto, if you put command axis auto can be used to re-enable the MATLAB automatic thing. So if you put axis auto, automatically that will get re-enabled. So here you can see automatically it will come to the original thing. So as I already told you, all these things are already available in the f of x, or it is available in the MATLAB examples, okay, in demos. Then some of the other aspect ratios for the axis that also we will be seeing. See, axis equal, sets equal scale on both the axes. Square sets a default rectangular frame of a square. Then axis normal, it sets a default value. Then axis if you give, it freezes the current axis limit, and axis off removes the surrounding frame of the tick mark. Okay, so these are, it will remove the axis itself because axis is having a boundary. So these are some of the axis commands. Then next is multiple plots. This is what somebody was asking me, how to draw multiple plots. There are 3 different methods of drawing multiple plots in MATLAB. One is using plot command itself, you can do. Using hold command, you can do. Like in plot command itself, you continuously give x1 comma y1 comma x2 comma y2 x2 x3 comma y3. Then it will plot the multiple plots in that itself. So that is one way to write the plot command. Hold is you write a plot x comma y, hold on, then give plot x1 comma y1. Then what it does, it then hold off, then automatically both will come in that. Then using line command, using a line command also you can draw multiple things. So that we will see step by step now. So first of all, to draw plot command. So plot, see here I've already told you this is the plot command. So plot x1 y1, plot x2 y2, plot x3 y3. So you define all x1, y1, x2, y2, and you just give this command. Automatically 3 different graphs will come in that. So first of all, we will see that example. So this is a very small example where x1, y1, x2, y2, x3, y3 are defined. Then plot I am giving x1, y1, x2, y2, x3, y3. Okay, so again I'm explaining. See x1, this is your y1. Similarly, x2, y2, x3, y3. Then plot x1, y1, x2, y2, x3, y3. Multiple title I'm giving as multiple plot, x label, and this. So this program, let us try now. Okay, so this is x1, y1, x2, y2, x3, y3. So what you can do is this whole thing, you can put it in a M file and save it in some name. And if you call multiple, say I'm saving it as multiple plots. And if I call, automatically this will plot. So this whole thing, when it is a whole program, you can save it as in a M file also. So now the multiple plots would have come here. So you can see here the multiple plots x1, y1, x2, y2. And if I give a label also, it will give me the label for all the three. So those things you can do it by yourself step by step. So next is using hold command, how to do it. So hold on and hold off are the commands for using this. So let us see the thing. So again, it is the same thing. You are writing x, y you are just defining. Okay, x and y you're defining. X1, x is a common thing I'm using. I am just defining y1, plot x comma y1. I'm holding it, hold on. Y2 I'm giving x exponential 2, that is my y2. Then plot x comma y2, hold off. So what will happen? This is holded and then this is plotted, and when hold off, then both will come together and grid on. So this is a simple using hold command how to draw multiple graphs. Okay, so this is to multiple plots, how to do using hold on command, hold on and hold off. Then next is same thing using line command also you can do. So line x data and y data if you give, you can, there hold on hold off is not required. So x is defined, y is defined, then x2 say x is defined and 3 graphs you're going to draw. One is using plot command and 2 using line command. So here y2 and y3 is given, so they are drawing some lines here. So in this case, again I'm just taking here, in this case you need not, single by plot only is given, but you do need not use hold when you use line command. Okay, so here in this case also you can see here all these things, multiple plots are there without using hold on and hold off. So there are different, not only this, there are different other methods. That's why I'm saying MATLAB is like an ocean. You can do a lot and lot of things using this. So for that, what is necessary is how to learn, from where to learn. So that I have given you an example where to, like I have given you an idea how to go to help and search for things and do it. Everything, not only this. So when I learned, I didn't learn from any of the courses or I didn't go anywhere. I just learned it from these examples only. I learned fuzzy logic, I learned neural, I learned GA, PSO, everything just by going to the help of MATLAB and MATLAB file exchange. MATLAB file exchange also I'll show you. So before that, next we'll see the style. So now everything was drawing only, we were just drawing straight lines or all blue color or some same color. Now we want to change the color, or you want to change the dotted lines or star or anything like that. For that, you have commands in MATLAB. For color, you can give different colors like red, green, yellow, blue, or line styles you want to give solid, dash, dotted, or point marks you want to give like star, like zeros or plus. These things, what you can do is plot x comma y, and third will be the color. So if you want to give the color, you have to put it within single quotes. Say, and if you give the color and dotted like this, it gives you dotted lines in yellow, and this will give you dashed lines in green. So all these things are the different ways. Here a colon should come, and then if you give a star, the line will be in star, like it will be marked, and here a red color, 0 zeros will come. So these are the different ways how you can make the style options. There are different other styles. Say for the color style, you can see here for yellow you will be giving Y, M for magenta, cyan blue you want C, R, blue B, G green. So these are things, and for point styles and the markers are also given here, solid, dotted, dashed, or all these markers are also available. And in case if you find, say what I feel is when you want to draw a graph or something, if you have the data, you just call the data and you just plot, like call the data and go there, and I told you an option. When you plot it, you can go and edit the figure there. So there it is graphical. You can just go and put the dotted line, you can change the color instead of writing commands. So that is very simple compared to writing commands here. So here, this is a very simple example of with colors, it will be plotting. So let us see that. Here T I have defined, Y1 and Y2 also I have defined. Okay, and plot. In plot T comma Y1 it is red color. T comma Y2 it is magenta with zeros. Magenta will be drawn, it's not a straight line, it is zeros. And X label I have given, Y label, title and grid on. So let us go and see the graph. So you can see the graph, red color and the magenta is 0, 0, it is plotted. So when you want to give a some style to the graph, that you can use these commands. The next is legend. You want to write a legend there at the top, then you can use this legend command. So legend is within single quotes, you can give the string. So when you, or you can see the line style. Say you want to write a legend, the line style is that magenta with 0, 0 we gave. That is magenta with that 0, 0 is your voltage. If you want to give like that, the line style here you'll be giving magenta 0, the string name, that is voltage. Then you will give the line style, again the line style for the second string within you have to write for the second string. That may be red with dot. If you give, the second will be this is for legend, writing at the top. I'll just show you what is a legend with an example, you will understand. So legend position also. Say you have a graph. Legend is what you write it here. So you want a circle magenta, so you'll write circle, like that circle magenta line will come here and you'll say it is a voltage. So at this position, whether you want it in the right corner, you want it in the center, you want it in the left corner, that you will be just giving it with the position. Okay, it's the actual best position. It will apne aap, oh, 0 give, if you give 0, it will choose it by itself. Upper right corner you want, you give 1. If you want in the left corner, 2, like this, you can give it. Or if you want to switch it off, legend off. So there is an example for this. So here cos, sine and 2. Okay, so let us see what's coming, then we will define it. Position is 2. Okay, so here, so this is the graph here. So one cos graph is drawn and one sine graph is drawn, and its position is 2 here on the right corner up. Okay, so this is how you will define it. See, cos, sine. So here in plot itself you have given x comma cos, and you have given how should it look. Okay, the style minus, since dot r. Okay, so here it is not only 0, it is a dash 0 dash 0. So that is here also dash dot dash dot. So that is what is given here. Okay, this dash is that, and a red O. The sense it will draw in red, but it is not only 0, it is, there is a dash also. The line will come and the dash will come, dash and a dot. So this is how you will draw the legends. Then subplot. So in this plot itself, I want to have different plots. I want one plot here with different axes. I want a plot here with different axes. I want a plot here with different axes. So for that, you draw what is called the subplot.